Hey, welcome to your own channel, that is Internet Quality Academy. The channel is for the quality control engineer, civil engineer, and the site engineer who are working in the construction projects. In this channel, we are discussing about the construction procedure, quality control procedure, and the strategies which is required to get success in the construction industry. So, if you are a construction professional or you just curious about to know a construction procedure, this channel is for you. And if you're new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. In today, I will discuss about a very important topics of the construction, that is structural drawings. What is structural drawings? What is the purpose of structural drawings? How to read the structural drawings and how to get success to fulfilling as per the requirements at the construction projects. That all we will discuss in this video. So stay tuned until the end to get the full information about the structural drawings. So let's open my mind map about structural drawings. The first thing is, what is structural drawings? That we need to know. Before that, we need to know what is the structure. Structure is the element of a building or anything that carries the whole load of the structure and transferred to the soil safely so that it can sustain long time. That means it is the load bearing element. Okay, so the load bearing element is the structural element. So these things is a structural drawing, is specialized type of technical drawing that provide details, visual and dimensional informations about the design and the arrangement of load bearing elements, components and systems within the building or a structure. So how this element will be distributed? What will be the thickness, what will be the depth, what will be the reinforcement, how will be the beam column junction, how it will be placed in the side, or how it will carry the load in terms of concrete or reinforcement or any structural element, that things to be in place in the structural drawing. So what the drawings is mentioned, that is structural drawings. So these things is the what is structural drawings. The next is, what is the purpose of the structural drawings? Why we prepare the structural drawings? The purpose of structural drawing is to convey detailed and precise informations about the design and the constructions of the load bearing elements and systems within the building or a structure. So it is the detail how the load will be placed. So what will be the beam, what will be the column, what will be the slab, what will be the staircase? So these things, that the dimensions and the reinforcement or any other structural elements, how it will be placed at the side, in the inside the beam, column, slab or the foundation, that things to be in place. So that's why we need to prepare the structuring. That is the main purpose of the structural drawings. The third point is symbol. So in structural drawings, there in any drawing there a symbol is there. So you need to know what is the symbol, that is symbol of material, that is concrete, structural element, column, beam, how it is mentioned in the drawing, that we need to first point it out that the drawing has this symbol. So these things to be taken care whenever we are reading a structural drawings. The next part of the structural drawings is scale and units. Not only the structural drawings, this is the main part of any drawings. You need to know the what is the scale and what is the units. Understanding the significance of scale in drawings. So you need to know the what is the scale, maybe 1 in 100. In any engineering, the first things when you start drawing, we need to know the what is the scale, 1 in 100, 1 in 20, 1 in, so we need to know what is the scale of the drawing and how scale affect the measurement and the dimension. Suppose any dimension is not there, but you need the drawing dimension. So if you know the scale, then you can easily find out the dimension from the drawing. So you need to know what is the scale and the units, and how the interrupt measurement of accuracy using the unit. So this thing is the scale and unit you need to check of the drawings. The next part is plan view. We all know that there is a plan, there is elevation. So first things we need to know the plan. Suppose it is a slab. So you need to know the slab plan. What is the slab thickness, what is the slab dimension, and how the beam is arranging in the slab to take the load from the slab. That is to identify wall, columns, openings, trace on the plan view, and the different all types of the meaning. So that things we need to know. If there is any openings, if there is any cutout, why it is purpose, and what is the purpose of the cutout, and what is the dimension, what is the slab dimension, that you need to know a plan view. So first things you need to check the scale, then what is the symbol used in the drawing, then you need to check the plan. Now when you check the plan, next things will become is the what is the elevation. Now You need to know the elevation views. Without the elevation view, you cannot say the what is the thickness and how the reinforcement is distributed, or how beam or column is connected, or any cutout how is then, or any structural elements you need to insert inside the concrete. So that things you need to know only from the elevation. Then identifying features like facade, parapets, and external cladding. How you know that things from the elevation drawing. So from the plan points, you need to check the what is the elevation. In elevation, you will see there is a facade. Now, to take the facade, you need the structural support. How you take the structural support? You need to be insert the structural element inside the beam, column, or the slab, whatever. So you need to ensuring if there is any structural element that you need to take care whenever you're doing the finishing work. That's why you need to know the elevation. Then the height and the vertical dimension. That is also you need to know the what is the vertical dimension. If you just don't know the vertical dimension, the column cannot be made, or the depth of the beam cannot be find out. So these things you need only from the elevation. The next part is navigation of sectional view. Now we have checked the plan view, that we all know there is a arrangement of beam, arrangement of slab, arrangement of structural element. Now the sectional elevation is need, because how it will be. So you need to identify foundation types, floor system, roof structure from sectional view. Now there is a beam, there is a slab. Now if you don't know the section, then how the reinforcement is arranging, that things you need to ensuring from the section point of view. I will show you a drawing, in detail drawing about the structural drawing, and I will explain that how you will read the drawing. And then the sectional point of view, you need to know the structural element, that is how the reinforcement is done, how the beam column junction reinforcement is detailing, that everything will be in the sectional view. So this thing you need to check from the structural drawing. Then detailed drawing. What is the detailed drawing? That examining example of full detailed drawings such as beam column junctions and reinforcement arrangement, that I already informed how the beam column junction, because it's the most important part of a structure, the beam column junction. How this beam column junction will be there, that should in the detailed drawing. So in the structural drawings you need to check the beam column junction also. And graining inside, how elements come together in detail. Now how they are interconnected and how they are resting one after another, and how they are placed, that should be in the detailed drawings. And whenever you are reading the structural drawings, the details you need to take care. Then foundation plan, of course, beam plans, sectional plan, column plan. Now when this load will go to the foundation, and after foundation it will go to the soil. So you need to identify the footings, piers, slabs, and foundation plan, and understanding the positioning of foundation in relation to the rest of the structure, how this foundation will be placed, that you need to take care, or you need to read whenever you are reading the structural drawings. Because if the foundation are not in place, then the eccentricity of load will be there, and there may be a chances that the failure of the structure. So whenever you are planning, you should be taken care of the foundation layout also. The next is structural load details. That whatever the structural load, that you need to ensure as a site engineer or the quality control engineer, you need to know the symbol of the various loads of the structure that is withstanding, or it will be transferred. That is live load, snow loads, wind loads, earthquake load, or the seismic load, that all load to be carried out by this structure. So you need to ensure the what type of load is there, that you have to take care. So these are the structural load details that also you need to take care whenever you are reading the structural drawing. Then the structural notes. Understand the significance of structural notes on the drawing. See, any drawing there is a notes, and often we just neglect that part. But this is the most important part. There is a thousand of notes is there, and that notes is very much important whenever we are doing the work at the site. Maybe it's note, the cover will be there, what type of steel will be there, whatever the grade of concrete will be there. So that is the key component of a structural drawings, and you have to read that one whenever we are reading the structural drawing, in order to get success for the completion of the structural element or the construction of the structural element. So these things you need to take care, these 10 points whenever you are reading the structural drawings. Now we will see our structural drawings and practical demos, how we can read the drawing. Okay, so these are a beam these are the slab drawing. See, you can see there is a beam. There is a beam RB3, RB4A, RB1, and these are the slabs. So these are the structural arrangement of a slab, and how the beam is placing, that oral is mentioned. So from there you can find out there is a beam, there is a beam, there is a beam, there is a beam, blah blah blah, and there is a slab. So these become the your plan view. Now you want to know the how it will arranged. Let me see. See, this is the typical beam section. These are the simply supported beam. Okay, these are the support, these are the support, these are the support, and this is just continuous. Now how it will be arranged, the reinforcement, how it will be arranged, the detailing of the reinforcement which is required to know in order to complete the construction of the beam or any structural element. How? See, there will be a list. In the list you can see the beam number is there. You need to check what is the beam number. Beam type is there, and the beam size, width and depth. So from this table you can easily find out what is the beam. See, RB1. Now where is the RB1? Here is an RB1. See, we can from see there RB1 is continuous simply supported beam. So there is a 1 support, 2 support, 3 support, 4 support, 5 support. Now this beam is RB1, and what is the size type of beam? 2A. And what is the size? 250 and 450. Now it is elevation of the beam. Now what is the elevation? Top of concrete also is there. So the beam top of this will be this elevation. So you need to, whenever you are doing, you need to be taken care of this elevation. Now here you can see reinforcement A, B, C, D, E, F, G, S1, S2, X. See here A 320, 220 is mentioned. Let me see again this. See, here it is A. A means is the continuous top reinforcement. So what is the in any beam is a top beam, top reinforcement, bottom reinforcement, and the shear reinforcement or the shear links. So here it is continuous reinforcement. It is A, and you can see the B is the extra at support. C is the extra support at mid span. See, it is the end span and it is the mid span. So there will be difference of structure and difference of loading pattern. So according to the loading pattern, there will be changes of the reinforcement. So here you can see C is the intermediate extra rod at the support. Now if we come to the bottom part, see, bottom is also D is the throughout bar of the beam, and E is the in the mid span in the bottom. And how it is being arranged, why this beam this is not in the top and why this is not in the bottom. Now for that you need to take care of the beam bending moment diagram and the shear force diagram. According to the beam bending moment diagram and the shear force diagram, these are placed. So if you want to know all these things, you need to be taken care of this beam bending moment diagram and the shear force diagrams. Then you will understand why this extra bar is there. But at a side, whenever you get these drawings, you will to be ensured that whatever the extra bar, whatever the main bar, and whatever the extra bar at the mid span or whatever the extra bar at the support, that you need to be taken care. So then all things is checked. Then A, B, C, D we have already seen. Now again check this. Now from A, we are already understand this is the continuous bar, that is 320, and C is the extra support, that is 220. Okay, now the link bar. Now see, you can see link also. There is a X, X, X. X is also mentioned from the support X, that is an S1, and here it is S2. Why this is different? Because these are different according to the shear force. The link is taking the shear force. So according to the shear force design, these are spacing of the links will be changed. Let me see. These are the at support S1 and the midspan is the S2. See, there is a 8 125 center and 8 200 center. What does it meaning of 8 tor 125 center? That means the diameter of the bar is 8 and its tor means that means TMT bar or HYSD bar, and at the rate 125 center. That means the center distance of 2 bar will be 125 mm. So whenever we will check at the side, we will check the center distance, that will 125 or not. And here it is C S2, that is the mid span. It is 200 center. That means at the support it will be 125 and the mid span it will be 200 center. Why you want to know this? Because whenever you are arranging all these things at the side, you need to be very careful whenever placing the shear links or anything, that the spacing of the bar is different. So you need to check now. And see, we have see x. So what will be the x? That means what will be the distance of S1 and how much length we will place the S1 and how much length we will place the S2. See here it is mentioned x is 1300, 1300 depending upon the beam type and its distance. So these are the beam reinforcement, how it will be placed and what will be the length of the extra bar at the support. You see here it is when 0.25 of greater of L2 or L3. L2, what is L2 is the dimension of this span, or L3 is the dimension of the other span. So it is carrying these two span load. Okay, so what will be the rate? 0.25 greater, whatever is the greater. Maybe suppose it is a 5 meter or it is a 6 meter. So 0.25 into 6 meter is a 1.5, or so whatever is the greater, that will be the length. And in this part also, or which one will be the greater, that will be, so this plus this, and in between whatever the column dimension, that also you need to place. So suppose it becomes 600, it becomes 600, and column is it's another 500. So 600 plus 600 plus 500, that will be 1.7 meters. So it will be 1.7 meters, say for example. So this way, same way you also calculate the extra bar at the midspan, and the same way you have to calculate the length of the extra bar at the bottom. See 0.85 L1, it simply is L1 is the clear dimensions of the span. So what will be the length? That will be the 0.85 of the clear dimension. So these are the reinforcement you need to be check at the side. Now another part of the structural drawing that you have to take care, that is the beam column junction, how the reinforcement is arranging at the beam column junction. See here, from this bond length is for type 2 1 bar, and bond length or 12.5 of the diameter. So what will the bond length? That will be whenever this beam reinforcement is entering into the column, from that point whatever the requirement, here is mentioned bond length plus 12.5 of the bar dia. So if it is a bond length, that is the design part, the design team will give you the what will the bond length and plus 12.5. That means if it is a 10 meter 10 tor, there is another 120 will be added, and if it is 8, another 80 will be added. So this will be the bond length. So whenever the reinforcement is entering into the column, you need to be ensuring what is the bond length to the properly mentioned or not, or as per the drawings we have provided or not. You have to be very careful whenever we are making the beam column junction, because the beam is supporting on the column, and it is transferring all the load it is carrying from the slab, and the load from the dead load or whatever, that is transferring to the column. So these beam column junction to be very proper. If it is not, that there will be chances of the structural failure. So you need to take care this one. Now as we mentioned that there is some cutout. So how to do the cutout also? If there is a cutout, and what will be the cutout details, and what will be the cutout of reinforcement detail, that also need to be taken care. See here is a this is a water tank, and how you will do the water tank. If there is a water tank, there will be changes. See here it is a mention, the dimension of the slab is increasing by 150 whenever we are placing a overhead reservoir, because it's carrying it will be the point load or the concentrated load. So how this will carry so the loading pattern or the reinforcement detail pattern has changed. So these are all the things you need to be taken care whenever you are reading structural drawings, because the success of the structural component is determined by the how you are implementing the structural drawing at the site. So these are all the things required to know about the structural drawings, and I hope you found it useful, and please let me know your valuable feedback so that we can grow together. And if you want to know anything about the construction procedure or the quality control procedure, please let me know so that I will also come with the more content like this. Thank you very much for watching me. And once again, if you are not subscribed me till now, subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. Thank you very much.